Okay, now it's recorded. So welcome everyone to June 24th SIG Apps meeting. My name is Janet Guo. I'm going to be hosting us today. We also have Adnan today on the call who's co-hosting. So I'll share the agenda in the chat so that we can follow along. Today we have two announcements. The first one is that Kubernetes 1.15 is out, so that means supported versions of Kubernetes are now 1.13 to 1.15. And then we have a new sub-project under SIG Apps. The sub-project is the execution hook, and we have Adnan today to talk to us more about what it is. And let me hand it up to Adnan.
All right, so so basically this repo is for a sub-project for running arbitrary hooks in your containers. Like for example, you can actually use this for running quiescent and non-quiescent hooks for supporting snapshots. So basically, you run the freeze commands to actually freeze the application before you take a snapshot, and then you run the unfreeze commands to unfreeze the application post the snapshot. So this is the primary goal of this sub-project, but you can also use this to run other kinds of arbitrary commands if you want. The design is basically around like having some CRDs for modeling execution hook and also hook actions or the commands you want to run. Then the controller will be responsible for running the hooks for you and surface the status of the hook execution through the status section of the execution hook CR. So yeah, let us know if you have any question regarding this new sub-project and new repo. Yeah.
So does anyone have any questions about it? If not, I'm going to start our discussion topic. The first one is the stateful application data management API cap, also proposed by Adnan. Let me hand it off to Adnan.
Okay, so Janet, maybe you can also open the cap.
Do you want to
yeah.
present?
Oh, well, yeah, I can also do. Okay, let me present first. Oh, share. Okay. That's cool. Okay, can everyone see my screen? Janet. Okay, cool. So basically, this cap is for proposing a new API we call stateful application. So the idea is actually to use this new API to support data management semantics for stateful applications. So basic application that maintain some persistent states through persistent volumes. So the idea is that we can actually use this API to support snapshot backup, cloning, restoration, and rollback operations declaratively, well, mostly actually. So this API structure, let me see if I can actually pull this out. Oops, okay. There's actually two files in this. I'm gonna try to jump to the structure diagram and see if I can actually show that. Okay, cool. So this is the basic API structure. So it's actually centered around something called stateful application, which is sort of like an extension to the application CRD that you can not only you can actually describe the application metadata, but also you can actually use this as a bridge to do data management tasks. And so we have CRDs called application snapshot and application backup for supporting snapshot and backup operations. And there's also a dedicated CRD called application rollback for supporting in-place rollback of an application. So the dotted lines here means basically the direction that you can actually take. For example, you can actually take a snapshot of an application, or you can also do a import of a backup into a snapshot. On the other direction, you can do application restoration by creating a stateful application that has a source that points to a snapshot, for example. Or you can also restore an application from a backup directly by pointing your stateful application to a backup resource. And rollback works similarly. So you can do a rollback to a state captured in a snapshot for an application, or you can actually restore to the state captured in a backup. So we try to make this API kind of like having a symmetric structure so that you can do different kinds of operations depending on the source of your operation. And so, any questions so far? Okay, so we have a lot of details in the CAPs. If you're interested, definitely check out the CAP and see all the details about this new API. I won't jump into the details of every CRD, but yeah, definitely if you're interested, take a look at the CAP. I guess now I'm gonna show a demo of this some implementation of this new API. So the example I'm going to use is a MongoDB. So basically, assuming like you have a MongoDB application running somewhere, you want to take a snapshot of this MongoDB application. So let me show you first. I'm going to use GKE for this example, and also I already have the GCE CSI driver, GCE PD CSI driver installed. So I'm going to use GCE PD as the persistent storage for Mongo. So I already have an application running here. So the Mongo is already running. It's run by a stateful set with 2 replicas. So the first thing I'm going to show is to take a snapshot of this MongoDB instance. So let me actually show you. This is how the application snapshot CR looks like. So you can see it has a reference to the class or the application snapshot class. So an application snapshot class basically defines common parameters used by the snapshotter for a class of applications. And it also defines who's the snapshotter for this particular application. So only the snapshotter with a matching name can really handle this application snapshot request. So basically other controllers or snapshotters, they will basically ignore this if they are not the one that should be responsible for this. So we also have a stateful application CR here, which represents the Mongo stateful application. So you can see it's actually pretty simple. So it basically has a reference to an application CR, which describes the application metadata about this MongoDB instance through this application name field. And another interesting thing here is the source in the application snapshot object. So you can see the type of the source in the application. That means I want to take a snapshot of an application. And here the application name actually points to the name of the stateful application, which represents the stateful application that I want to take a snapshot for. So let me show you the class. So the class basically defines a few things, like what I said. Like first of all, it defines who's the snapshotter for this particular class of application, and also it defines the quiescing and unquiescing hooks. Here you can see the pre-hook or quiescing hook definitions, and also post-hook or unquiescing hook definitions. And there's also something called deletion policy, which defines what happens when you delete an application snapshot. Whether you want to keep the snapshot around, or you also want the underlying snapshot to be removed as well. So any questions so far? Okay, so here for the pre-hook, I'm just basically running a Mongo lock command, and for the unquiescing hook, just basically unlocking the table, unlocking the database. So the first thing I'm going to do is actually to create the snapshot. So this will trigger the snapshot process. So if I do so you can see here we have a bunch of events that shows what happened, during the process. So first of all, we retrieved and persisted the application metadata, which means like basically the set of Kubernetes resources that make up the application. In this case, we have a MongoDB stateful set. We also got a service that we want to capture. There's also an application CR that also captures as part of this snapshot. And then after that, we run the pre-hook. So you can see we actually executed one pre-hook. And then after that, so once the application is freezed, then we start the volume snapshot process. So the volume, so here we got two replicas. So we actually have two PVCs to snapshot. So that's why here, we basically created two volume snapshots for the two PVCs. And then we have something called application snapshot content, which is a non-namespace resource that basically capture information about the underlying snapshot. So yeah, so once both volume snapshots become ready, that means they are, they're done. Then we run the post hook to unfreeze the application, and then we call the post process done. So you can see now that the status of the snapshot becomes bound. That means it's usable. So you can actually use that to do application cloning or restoration, those kind of things. Okay, any questions so far?
So you just said that application CR is created by...
Yeah, it's actually created by the user for an existing application. So I can show this, I guess. So this is the original definition of the Mongo application. So you can see that it got an application CR, which also specify the component kinds of this application. It got one service and one stateful set, which is below, basically. So we use this label, this app label to, group all the components together. So now what I'm going to show is actually to use this snapshot to do a restoration or clone, whatever you want to call it. This is what I'm going to do. As before, actually, so I do that, I want to clean up the existing app. So because otherwise, I might not even have enough resources to run the new clone app. So what I'm going to do is to delete this existing Mongo instance. And after that, I'm going to do a restoration of the app into the same namespace. Before I do that, this is how the CRs for the cloning operation look like. So what I'm doing here is basically having another stateful application, but this time you can see it actually has a source field, which points to the snapshot I just created. And there's also something we call value substitution rules, which allow you to specify things that you want to replace. For example, you want to replace certain values in the labels or environment variables or in annotations or even names. In this case, I just want to change one of the environment variable from one value to the other because of the change of the name. So I'm gonna name the new application or the clone application Mongo clone to just make it different from the original application in terms of like naming. So because of this, we also need to change some other things. Like for example, this label actually points to a basically specify a label selector, which we also have to rename. So this basically creates the stateful application object and then triggers a restoration operation. So this will go back to this. So you can see this new clone application was created because of this restoration operation. And if we actually jump into the details of that, you can see all the labels are also renamed. So the old labels use Mongo, and now the new labels all become Mongo clone. And if we further go down into an individual pod, you can also see that we actually also renamed like the volume. Yeah, so you can see we also actually renamed the PVC that's attached to the pod as part of this restoration process because of the name the name change of the application. Yep. So now the new cloned MongoDB instances have been running. So any questions so far?
Hey, yeah, I have one question. Where is the snapshot content actually stored? Like the actual.
So one thing I think I forgot to really emphasize is that here by a snapshot, we mean a snapshot that has everything. It basically has your, so it has a copy of each of the component or Kubernetes resource that make up your application. And also it includes snapshots of all the persistent volumes of the application as a whole. So then by restoration, we are also restoring both the application objects, but also all the work volumes. So basically here, one interesting thing to show is this Mongo clone. So if you see this PVC, this is basically the PVC used by the first part of the cloned MongoDB instance. So you can see this PVC actually has a data source, which points to a volume snapshot that was created as part of the application snapshot I just showed. So this is basically the way we use for doing volume restoration. Yeah.
Did you have your speaker on?
I think so. Otherwise, I guess people will be complaining. Oh, no. Okay, yeah.
Because I think Adnan just said something.
Oh, sorry. I didn't turn on my speaker, so I didn't hear what you just said.
Oh, sorry. So my question was where the snapshot content was actually stored. So you kind of shown how the volume snapshots are stored, but what about the actual resources?
Okay, so actually by default we just persist the application config information onto a persistent volume attached to the controller. So basically by default, we just persist the application config to disk.
I see, okay.
Yeah. But the API also supports other kind of storage options that people can actually just extend.
Thanks.
Mm-hmm. Okay, any other questions? All right, I think that's about it. So yeah, like what I said, if you're interested in this proposal, and definitely check out the CAP and comment on that. We would love to hear feedbacks on this CAP from the community. Yeah, thanks. Okay, let me stop.
Did you turn off the speaker?
Oh yeah, let me do it. All right. Okay. Okay.
All right. Thank you. Let me go back to present. The next one on our agenda is the sidecar cap. Do we have anyone on the call to talk about it?
Yep, I'm here. So yeah, this PR is just to change the cap to be implementable. It's we've filled out all the sections now and decided on pretty much everything. So it was mainly just, does anyone think there's anything missing? I will also be going to Signode tomorrow evening to ask them if they have any final questions, remarks, etc.
Okay, sounds good. So that's our two caps to be reviewed. So if anyone are interested, just take a look at the link we posted in the agenda. So now we've gone through all of the items in our agenda. Is there anything that anyone wants to bring up for open discussion? Okay, so think we can end today's meeting earlier. And thanks everyone for coming. See you next week.
Thanks, everyone.
Meeting.